Marcus Lagergreen. Okay. I'm Yolande Poirier from Oracle Technology Network, and I'm here today at Devoxx interviewing Marcus Lagergreen.
Nice to meet you. Nice to be here. Thank you.
So you're working on Nashorn.
Yes,
right?
to be more specific, I'm actually on the Java language team, working on invoke dynamic and dynamic languages on the JVM in general. But the specific aspect of that, the last 18 months, have been trying to get a JavaScript runtime based on invoke dynamic out the door, which is the Nashorn project.
And what does it mean?
Dynamic languages, or rather, let me step back even further. The JVM is a very good runtime. It has a lot of stuff in it that runs Java really well. It has automatic memory management, world-class garbage collection, lots of industrial strength code optimizations. If you just give it bytecode. And bytecode is an independent file format. So, in theory, and people have been doing this even since like the mid-90s when Java first came out, implementing other languages than Java that compile the bytecode and put them on the JVM. And the benefits are many because the JVM, like man-decades of work, has been put into making the JVM a competent runtime, both like with automatic memory management and the code optimizations. So, the problem, of course, is that it was written to run Java and not other languages, even though, I mean, it's possible to implement anything, but it's usually slow. So invoke dynamic is a new bytecode, a mechanism that has been with us since Java 7 came out, but is only now starting to be picked up, that enables you to more efficiently compile other languages than Java to bytecode and run them on the JVM, because it will save you an immense amount of work to have all this stuff that's in the runtime already. It's actually a project called the Da Vinci Machine project, which is an open source effort to modify the JVM so it becomes not just a Java runtime, but a polyglot runtime that can be used for all kinds of languages. And then we need some new mechanisms, which is one of the invoke dynamic bytecode is one, and the Java lang invoke package with the support framework around it is another. So in order to proof of concept this, it started as a proof of concept maybe 18 months ago. Could we implement a dynamic language, something not Java, that compiles the bytecode and make it run efficiently? Because, I mean, SpiderMonkey and V8 and all kinds of like native runtimes written in C++ that implement JavaScript exist, so why write another? Well, that was the original idea, to get, I mean, if we can get a much smaller program than these huge self-contained stacks going on the JVM, we would prove that we've gotten to a place where Java or the JVM is a multi-language runtime and not just a Java runtime. And it looks good. Yeah.
So why is JavaScript so popular, or?
You know, I don't have the slightest clue why JavaScript is so popular right now, but everyone seems to be re-implementing everything in JavaScript. I mean, it's good for market share, and it's good as a vehicle for us to ride, so we can sell the JVM as a multi-language platform or make it viable as a multi-language platform. But personally, I don't understand it. But I'm happy to see what I can do for the community.
Do you have like a good example, an example of how it's used today?
Today, we're in the process of open sourcing the Nashorn project. I mean, the closest equivalent that's out in the open today is Rhino, which is a pure Java JavaScript runtime, but it's very old, it's very slow, and it doesn't use any of the new mechanisms for dynamic languages on the JVM. So we hope to be a viable alternative everywhere where Rhino is used today, which our performance benchmarks have shown that we are. I mean, we totally blow it out of the water now that we have specific tools to run other things than Java on the JVM. And I can envision many things that it can be used to. There's the Vertex project, which is using Rhino currently. There is Node.js is another native runtime-based project. It's very popular right now. As a proof of concept, we just took the Node.js source and stripped out all the native code, re-implemented it in Java and JavaScript, and it was surprisingly short undertaking to get it at least up and running, which proves that the pluggability between JavaScript and Java is another good thing, that you can call into the JDK from a JavaScript program and do some sort of hybrid solution, which makes it possible to write software very quickly, with a leg in both worlds. For instance, for I/O, which we use the Grizzly I/O library in the Glassfish server, and we just call that from JavaScript with our with the scripting API. And I mean, in theory, Rhino could do this as well, but performance has just not been viable given the existing mechanisms to implement JavaScript.
So it's going to be open source. What can people do, or developers do with the open source project?
We aim to release this in the Java 8 timeframe, and hopefully we'll get the bits out earlier, the way Lambdas are currently being rolled out in beta builds and already available. Developers can do everything that they do with JavaScript, and a lot of people want to use Rhino because you have this pluggability. It's actually the JavaX scripting API. It was JSR 223, which enables this hybridized programming between Java and JavaScript. So it's productivity enhancing because Java is very mature, the JVM is very mature. JavaScript, like using Java through the scripting API is very powerful. You probably want that as a JavaScript developer, and you can't have that if you have a native runtime which doesn't have a Java virtual machine under it. So I see that there are several killer apps in the near future. Our Node.js implementation, which we jokingly call Node.jar, is pretty good. We have the platform portability immediately. You don't have to recompile it. We deployed Node.jar on Nashorn using an ARM version of Hotspot on a Raspberry Pi card, and it just worked. And you can also consider things like in the Java EE cloud, you can put a Nashorn image with Node.js as a component there. So I see several like killer app possibilities, let's say, with this. Very simple to use, but time will tell if people will pick it up. That's why we want to open source it. We're the langtools team. We use the Java language. We developed the Java language, and dynamic languages support is part of that. But we really need help from the community because it's a huge undertaking to get this to be successful. And that's why we're open sourcing it.
So where can people find more information and when it's going to be announced?
Well, a lot of it was announced at Java 1, and there is this video online if you go to this year, Java 1's 2012 website, several sessions. I think we had 5 sessions touching on all the different aspects, everything from like internals, how we get how we implement the dynamic language on top of the JVM, the Node.jar. We had some demos. And I had a session today as well, which was about like type systems and adaptability, some internal stuff, but also maybe 40% of the presentation covered the Nashorn project and the progress we made. So that's probably going to be on the internet as well. And you can also follow me on Twitter, where I rant about JavaScript and why I hate implementing a JavaScript runtime.
And what's your handle?
It's my last name, Lagergren. So.
Okay.
I think my session was pretty well received. So, it's a pretty exciting project. It's a clean room implementation. We started from scratch. The codebase is significantly smaller than Rhino, and of course, since we have the JVM for all the heavy lifting, we didn't have to implement a complete software stack from scratch. So that's like the possibility of the JVM as a generic mechanism for running dynamic languages. So also check out the DaVinci Machine project, MLVM, the multi-language VM. You can Google it. It's open mailing lists. And then we talk about things like how we can modify the JVM internals to even better facilitate this, and things like that. So.
Thank you so much for talking to us.
You're welcome.
Today. Thank you for joining us.